Orna, please.
Okay. Hi, everyone. I'm Orna from the Foreign Trade Administration, and I'd like to welcome you all to our first Advanced Manufacturing webinar. Myself and Yariv Becher from the FTA, along with Sagiv Elad from the Export Institute, will be your POC for this sector. And I'd like to begin, well, I'll explain a bit what we're going to do this webinar. So we're going to start with Dr. Gilad Fortuna, who will introduce us to this, the basics of this sector, and then we'll try to understand how can we promote this technologies, these Israeli companies. And then we'll speak, we'll hear from two companies who provide solutions to the manufacturing process. So we'll start with Dr. Gilad Fortuna, who is the head of the Industrial Excellence Center of Shmuel Neiman Institute from the Technion. Dr. Fortuna will elaborate, will give us an overview of this world, what is advanced manufacturing, what is the rationale behind it, and will give us examples of verticals that can benefit from implementing these technologies. So, Dr. Gilad Fortuna, thank you for joining us. Gili?
Open your microphone, please.
Okay. Can you see the screen now?
Yes, it's fine. Continue,
okay,
please.
Okay, good. Thank you. So I will try to cover the advanced manufacturing from the rational point why we need it, what is the challenges and what is available today, and also what is Israeli national policy that we are now in the midst of building it up. So in the first slides, we are talking about the rationale behind advanced manufacturing. So that's really talking about the needs, why we need it. So the classical industry, or what we call usually the traditional industry, suffers from low productivity and is not competitive in the international market with low working salaries markets. And we think that by applying this advanced manufacturing opportunity that is only emerging now, we could achieve productivity and competitiveness. The same applies for Israel and also for the Western world industry as well. The high-tech industry in Israel is losing its production base because we don't have enough tools to produce them in an effective way with high productivity, especially when we have new products with small series. This new advanced manufacturing technology enables us to produce even in a small series, even the prototypes in a much faster and better production and with lower cost. And now, today, we have this large variety of advanced technologies that we are going to cover now, and innovative processes that offer the opportunity to what we call the fourth industrial revolution, or in many other countries like Germany, it's called Industry 4.0. Now, the third leg of this rationale behind the advanced manufacturing is the opportunity that we have here in Israel, where we have hundreds of Israeli companies. Most of them are startups in different stages that offer innovative products and processes and technologies to be implemented in the advanced manufacturing. So having those three legs of challenges and opportunity, we moved to discuss a little what do we mean by Industry 4.0 or by advanced manufacturing. And essentially, we are talking about applying as a system most of the technologies that we have on these slides now. So first, the massive digitization that was not available even 5 years ago. Of course, the Internet of Things, the IoT, where we can put huge amount of sensors implemented into the system and get information as much as we need in order to be able also to put control systems in the system and manage them with massive digitization. The second one is the big data analytics. In the past, we had to choose what we want to measure and what we want to analyze. Today, with the huge power that we have as the modern computers, we can take in all the data and let the computer with us together, but the computer does most of the work, analyze what is important and what is not important. So this data analysis enables us to control the real parameters in the manufacturing much better than ever before. The third one is the advanced smart robotics and what we call adaptive automation. We can change very fast specification of the products in the production line. We can make changes to new products few weeks or months after we get them into the market if we need with this adaptive automation. Then we have, of course, the new technologies of 3D printing, what we call additive and precision manufacturing, which enables us to save in materials, enables us to produce very precise, exactly what we need parts that we could never do before, even 10 years ago. You know that until recently, we used the 3D printing mainly for the prototype. Today, with the technologies that have evolved in the last few years, we can also manufacture in the same efficiencies. And this is a big change. We have the artificial intelligence, or what we call machine learning. This is a growing sector in our computerized world. The machine learning means that the computer itself can teach itself to learn from what it sees in the production line or in the development line and adapt new procedures, sometimes even without our intervention. Now, in regards to materials and surfaces of materials, we have the nanoengineering, which is enabling us to produce very high sophisticated materials at the micro level, and we have control. So when we talk about advanced manufacturing, is in implementing most of those in the production line, and of course it has to do with the development as well, because being able to integrate the development into production online really enables us to have a fast and efficient plant. I would like in the next few slides to cover very briefly what is going on in advanced manufacturing outside Israel first, and then later we will move to discuss what is our policy. So as you are now in the United States, many of you, so US Presidential Initiative really ended up in 2012 with a report that was invited by the president. It was a report prepared by a big committee that included the academia, the industry, the research groups, and of course the government. And at the end of this work, we could summarize most of the results maybe in one slide, which shows us what is happening in the design level in the United States. So if we look here, there is now a national network of manufacturing innovation institutes, and they are growing up, and they are communicating with the universities and the national labs on one hand, with the community colleges, also teaching new students how to cope with the new technologies so we can better implement them. We have the high-tech startups. We have them in Israel, but we have them, of course, also in the United States. And they are also now pushing the technologies into the manufacturing innovation institutes and applying the technologies for the prototype, for the lab shops, for the manufacturing, and for educational force that we need to build a new era. The large manufacturing companies usually could cope and be productive also in the past, but now if they do not implement the new technologies of advanced manufacturing, they will be left behind. So they are also now a part of the change. And all this goes into multiple manufacturing support centers around the United States. And also, as we discussed before, the large manufacturing companies probably can invest their own money in implementing. But the small and medium-sized manufacturers are shortcuts with budgets, so there is a national budget to cope for the small and medium-sized manufacturers. Now, looking outside the United States, And before I go outside the United States, maybe just mention that in the United States, the National Institute of Standard and Technology, the NIST, is leading the project, and they are working with many new institutes like Advanced Manufacturing National Program Office, with the National Network for Manufacturing Innovation. And we have a consortia today of both industry, academia, and government and research groups, which is called AMTEC, the Advanced Manufacturing Technology Consortia. If we watch the US Academy, MIT was the first to jump in the beginning, immediately after the president's report. In MIT, production and innovation economy was led with a group that stayed for about 2 years and mapped all the technologies. They ended up offering 7 major technologies that most of them I presented in the first slide. And now they have many programs in MIT. Berkeley followed up with an emphasis on energy, and slowly many more US academies, big universities are joining. Let's go outside the United States to see that this is a global trend. It's not only in the United States. In Britain, there is a program for the last 3 years called Catapult. It's a high volume manufacturing. It includes both institutes and government money, so I will not go into details, but the program is attempting to be as good as in the United States right now. In Germany, where the production base is bigger and remained strong, they still decided that digitization is the name of the game, and they call it Industry 4.0, and the Fraunhofer Gesellschaft Institutes are the major power of moving know-how from the universities to the industry with an emphasis on smart manufacturing. Also in China, which has, of course, a huge infrastructure of manufacturing, Jichu Zhongqin is the controlling institute running the program, but we have many agencies, the Camtex and the new dedicated venture fund by the government for the advanced manufacturing. China has committed the next 5 years program, 2016-2020, for doubling the production base, and they know that they cannot achieve it without implementing the advanced manufacturing. So they are going to stay there, and they are going to emphasize advanced manufacturing in the next years. Also, if we look at India, which is coming behind a little later, the government is planning to establish experience centers for advanced manufacturing. This is happening only at the end of 2016. If we watch recently some news that's coming from the government, then the Ministry of Department of Heavy Industry, while addressing a conference, took a commitment that the government is going to establish experience centers for advanced manufacturing all over the country. So they are a little behind what has happened in China and the United States, but they're catching up, and this is for sure going to be a big partner as well. Let's go now to Israel. We have a short time. The startup for advanced manufacturing in Israel are very competitive because they are coming with the know-how of a startup nation from Israel, and we have many startups that are already offering innovative and breakthrough ideas for the upgrading of manufacturing capabilities. We'll show in a minute few examples, and you will get a presentation by 2 companies a little more in details. Driven by both the government and the industry and the private sector, we have now a program of implementing both in Israel and leveraging it to the world. And we recently at the Samuel Neyman Institute tried to map the leading manufacturing companies that are really fitting into the advanced manufacturing. And we mapped at the beginning 150 companies, which are the leading ones. And you can see that the major of the companies is still dealing with advanced logistics and processes, which is the easier one to implement. But following up is the others, nanomaterials, additive manufacturing, 10%, sustainable manufacturing, robotic. So this is the percentage out of 150 companies that we mapped, and we are going to map more. And of course, we are going to get the details of the companies, and it's already available for you now. If we try to look at it as a system-wise, then the advanced manufacturing as a system looks like a complex of adapting the advanced product on one side and the smart manufacturing and enterprise concept embedded in, and the processes and technologies that we discussed are all getting into advance in science and technologies, which is the convergence of all the technologies into the manufacturing, and of course, collaborating with the R&D at all stages. It's a system that is going to be probably dominating in the next 10 years in the manufacturing world. Israeli national policy, we at Samuel Neiman Institute came out with a report. The report is in Hebrew, so we cannot share with you right now the whole report, but if needed, we can translate. We have started about 2-3 years ago. Yariv, who is going to talk later, was in Chicago. He prompted us to get into the subject. We found out that there is an opportunity here for Israel, and we are working with the government on a policy promoting tools and allocating budgets for the implementation. We have roundtables, we have a gap analysis study of the Israeli industries, both the traditional classical one, as well as the high-tech industry, the electronic industry, and so on. We are studying and promoting companies with technological solutions for advanced manufacturing, and we are looking for further international collaborations. And this session, of course, is one of the ways of pushing it ahead. We think that, like we did in the water industries, that you know, in the last 10 years, we need to involve the international standardization efforts of advanced manufacturing, and this is our planning. We are building in Israel excellence centers for advanced manufacturing, which will educate and help the industry around. We are pushing pilot projects for implementation, which should be also beta sites for going out with proven technologies. Many roundtables are going on now, and in this roundtable we have many representatives of the industry, of the academy, and for the research institutes. And the government is leading today with the Ministry of Economy as a leading role on this. We also have we are encouraging learning tools in the best class of industries. We did tour Germany a few months ago with the whole group, and we are looking forward to see other options as well to learn and adapt to the Israeli system. In the next few slides, we will go very, very fast. I want to show that we have companies available in any of the technologies. So if we look at nanomaterials, we have Menodia and Nanospan. It's all in the data that you will get or you already have received, so I will not go into the details. If we look at additive manufacturing companies, we have large companies, and here we are showing the smaller one, which are coming with new solutions. So Something 3D and Deep Tech are examples for additive manufacturing. We have robotics and automation companies. You see that all of them are established only a few years ago, so they need support to push them into the market, find the collaboration, but they have surprising, very well established technologies. Next generation electronics, we have also a few companies, and as we said before, the advanced logistic and processes is the first one that get most of the attention, because here we can leverage the productivity very fast by adapting them. You will hear one of these companies immediately. And I think after showing you that we have few samples of company from each, I think we urge ourselves and you to leverage Israeli companies' know-how in the relevant technologies to participate in the change in Israel and also lead in the revolution in the global world. So we have an opportunity here. The world is changing in front of us, and we have the opportunity to participate and even lead. Thank you very much, and I will be happy to answer questions.
Gili, for now, if somebody has a question, he is more than welcome to write it. But for now, I don't see anyone writing something. But Gili will send it to you later, and we'll reply to all in the email. So Gili, thank you very much for. Just a second, Boaz from Brazil is writing one. So we'll wait.
Okay.
But till he'll write it down, I really want to thank you, Gili, for being such an excellent partner and being and working with us through this to build and to have a good database on the companies who are working on this sector. So Boaz is asking, is there an event conference in Israel that we can invite people to?
Yes, as a matter of fact, we had already a few conferences, and we have one next week on Monday. So yes, I think we have more conferences than I expected 2 months ago. I think in the last 2 months we had about 4 conferences, and most of them were in English. Yes. So yes, we can send them, of course.
Okay, so I think both of the last ones were in very short notice, and the one that will happen next week was really short notice, and he's asking about exhibitions. Do you know?
Not yet, too early, but we should work on it.
Yes, but and everyone else, we were hoping that we'll maybe help to promote one. But there's nothing in this matter that is happening in Israel in the next, I don't know, anytime soon, the near future. So if nobody has more questions, then we'll continue. Gili, thank you very much for the presentation and the other ones during the day. So
I'm closing the screen. Thank you very much.
Thank you, Gili. So, okay, so just a second. Okay. So we'll continue. Yariv can't make it, so we'll speak about a bit about how can we promote this sector. So Gili gave us a really perfect, interesting presentation and overview of the sector, and also he also elaborated on what the government is doing in this field and what can be done to promote Israeli companies in this sector. So this presentation actually is a marketing presentation that you can use when you are engaging with the industrial companies. So every good presentation begins with the innovative ecosystem in Israel. You all know we have over 1,000 startups every year and over 300 corporates that have opened a center, mostly R&D centers in Israel. So you know all about that. I won't repeat what Gili said about the manufacturing process, but I'm sure you all listened very carefully, but I do want to elaborate on the manufacturing cycle. Well, you can see here, this is the categories that are based on a paper from MIT, of an MIT paper. Gili and his team built us a database, an Excel sheet of 150 companies that fit to each of the stages of the manufacturing, starting from advanced materials, nanomaterials, till sustainable manufacturing, like energy efficiency. We'll have Light Up that will speak about this category. And you can see we have a variety of companies, Israeli companies, that can match each one of the stages of the manufacturing process. Well, actually, Yariv Becher and I, we invite you to create engagement with industrial companies. And we are offering various services. We can help them do a scouting process. We can help them locate the most suitable company that can give them the best solution to the need what they are needed. And we also have funding. We have funds. We have funds like Berde Fund and R&D funds like joint R&D funds with Korea and Japan. We also have we can also help with the proof of concept. We can share some of the costs in order to help the companies take the first steps. And we can also do we can also match them and build them tours or a set of companies that can be the most suitable for them. So really, just a second. Okay. We're missing a slide, but I'll tell you, we have, besides this presentation that is handed to you, and of course we'll send all the materials after in the near future. You also have the database, the company's database. If you don't have it, so you are more than welcome. I'll send it as well. And you also have us, Yariv Becher, myself, and Seki Velad from the Export Institute. We're here to answer any question and be at your service. So thank you, and we'll continue now with the presentation of Noam Barnea from Stratasys, from WriteUp, sorry. Noam, I welcome you to join us.
Hi, thank you, Orna. So good morning, good evening, everyone. I'm Noam Barnea, the Director of Business Development at WriteUp. And what I will try to show you today is what is Industrial Internet of Things Engagement Platform. I'll try to do it in 15 minutes, which is what WriteUp is actually doing. Our statement is we help companies run their manufacturing plants efficiently. And we do it by looking at their energy consumption. So we are doing optimization for the whole energy process, and also resources optimization for all of their production and materials. So Dr. Fortuna has mentioned the Industry 4.0, and actually there are many aspects for it. What we try to do at WriteUp is to concentrate on the energy perspective of it, and talking about looking at the energy perspective. The new era of the Industry 4.0 is not because we have new energy sources in the manufacturing world. It's not because energy has been converted into different type of sources. So it's the same steam and compressed air or chilled water. The revolution is because we can do a deep analysis which is very focused in terms of what is the context of the data, what we want to analyze, and where we want to push the data in order to take actions. Why we care so much about energy in the manufacturing world? So 3 simple facts. Industrial facilities consume nearly a third of the world's total energy, and this energy is typically a top 5 cost item for any manufactured plant. And the worst part of it is that 30% of the energy is often wasted, and this is what we're trying to solve. We want to minimize the amount of wasted energy in the manufacturing world. I want to share some photos, real photos that were taken from a visit to one of the biggest factories in the US. Just to give you a description for the challenge, because in one end we have all this Industry 4 new abilities, but then actually when we come into factories, what we see is a sometimes very primitive sort of solution. So very old-fashioned sensors and some data logger, and the actual monitoring system. And again, this is taken from a real visit. Is a very old printer stating trouble exists in the system. So So the challenge is really to come into this traditional manufacturing world and to enhance all the abilities to be able to implement high-tech technologies and to bring also from our point of view, the energy perspective into the factory. So why we are important? What is actually our solution? So we make consumption efficiency data transparent to executive. That means executives now have dashboards that can understand exactly what is the consumption pattern of the energy, what is the total cost, what are the trends. So they can easily know if they are doing better or worse comparing to some other periods. We have a very specific KPIs, key performance indicator, to specify and show that engineers can fully understand where their energy is going. So they have full control and ability to visualize and see where the energy goes in all the supporting systems. That's also true for the operation officers that can understand what decision they need to take in order to optimize the energy usage. What we do, we join production data also with energy. So now executives and officers can answer questions such as how much energy is being consumed per a produced unit. Okay, so if we are talking about butters, producing butters, beverages, we are measuring and we can answer what is the cost for any Coca-Cola can that is being produced. Are we doing it efficiently? Again, comparing each period, and also we measure it in real time. So we can have real-time notification directed into the operation officers stating that something is wrong. There is a deviation from the known performance or from the baseline performance, and we pinpoint that. All of that enable techno-economical decisions. So when you understand how you use energy, and if your resource usage is optimized or not, you can and what is the cost of that, you can really take decisions. Okay, so you can, for example, if you want to change a compressor in the compressed air system, you can create a full ROI, return on investments, what is the cost of the compressor, what will be its efficient consumption that we'll bring into the factory, and we can calculate if it's worth to replace it or not. And overall, by implementing our platform in all the factory, so we map all the energy sources, supporting system, and production lines, and we create a stable system that creates engagement in the manufacture plant. If we look over the last three, almost 4 decades, we can see some improvement in the systems. So in the 80s, most of the systems were based on smart sensors that came into the market. Then on the 90s, there was some software to monitor, to give you some remote monitoring for the sensors. And in the last decades, most of the solutions were tackling the reporting area. So be able to produce some reports and to analyze the data. What we see that is the best advantage now in these days, we take all these sensors and logging and monitoring abilities as the basis for our data. And then we put everything in the correct context and we push it into the relevant teams. And by doing that, we create smart analysis that can push or drive smart decision making also in real time in the factories. By doing that, we can answer questions such as, are we running efficiently? Are we better than our competitors? Can we do better? Where can we do better? What should we focus on right now? Think of it, it's like a miniature battlefield in a factory. In the biggest factories that we have our system, we're talking about hundreds of sensors, a lot of data, big data. Dr. Fortuna was talking also about it. And this data, if we can't analyze it in a correct way, in an efficient way, if we can't push ready data that we know that is important into the relevant persons, it's really a waste of data. So this is now the right idea or the right operation that needs to be taken in an advanced system. Our system is a cloud-based system supporting, again, big data. So we have millions of records being calculated and stored in our database. We have thousands of connected sensors for many times, so electric sensors, flow sensors, temperatures. Also, we're taking data from the production floor, such as quantities of production data, and also parameters regarding the production process itself. We have a lot of built-in templates and unique KPIs, again, key performance indicators that help us to give by zero implementation a ready-to-go product that can be used at each manufacturing plant. So just I don't want to go in too much into technical description, but just to give you some short description of what we do when we first go into a new factory. So we are doing, the first thing is to do a mapping. So we map all the factory's energy sources. So we're talking most of the time about electricity, gas, water, and fuels. It depends at each factory. Then after you have all the energy sources that are feeding the factories, there is an energy center that converts energy. So it converts electric energy into compressed air, for example, or electric energy into cooled water. And so, and finally, from the energy center, energy is feeding the production lines. This is actually what it should do. It should help the production lines in order to produce the material. So we map all the factory. We help to install all the sensors. We validate the data, and we then implement the modules and all the smart KPIs in order to show this smart data. We have tens of customers in Israel coming from all over the manufacturing world. Some of food and beverages, Tnuva, Strauss, Tempo, Yafora, Iskar, Nirit, which are from the plastic industry. We have a non-woven industry, metal, and so on. So any factory which belongs into the traditional manufacturing plant is a prospect to us. We started last year a very big project in California, which is actually a research project that is being funded by the California Energy Commission. And it's been led by Berkeley, MIT, and Chicago. The idea is to evaluate the effectiveness of smart energy efficiency platform in the traditional industry. They chose LightUp platform as the research platform, so we are implementing our solution in 100 industrial plants in California. Already we are halfway through. We have about 40-45 factories in California. We are tackling the compressed air system, which is in many cases it's not optimized. We can tackle many energy waste over there. And what we created with this project is actually a new industry arena. So it's a first of its kind benchmarking arena. What we're doing, we are benchmark each factory based on its performance, and they are all shared the same information, and they can know what is the best practices in order to reach optimization and so on. It's a very interesting arena where all the customers are sharing data and can position themselves inside the manufacturing world in terms of their performance. That's it. Thank you, and I will be happy to answer some questions if you have.
So if you have any questions, you're more than welcome to write it now. If not, we'll send it if you have any questions later, so we can send Noam the questions and he'll reply all to you all in email. Before we move on to Dana, I just want to say that Erez asked about the scouting process, and I just want to say that if you have any specific requests regarding a specific company, you are more than welcome to send it to us, and we'll try to assemble a portfolio of companies that can answer this need. So please don't hesitate to send a request to us. And now we'll continue with Dana Tamir from Indegy. Dana, thank you for joining us. Please.
Hi. Good morning, good evening. Let's see. Why is it? Okay.
Yes, it's great, Dana. You can start.
Fantastic. So again, good morning, everyone on the call. So my name is Dana Tamir. I'm the VP Marketing at Indegy. Indegy is an industrial cybersecurity company, and I'll explain why industrial cybersecurity is so important for this market. A few words before we dive into cybersecurity. Why Indegy? Who are we? So the company was founded in 2014. We've announced the first version of the product a year ago in February, and today we have customers most of our customers, I must say, are in the US. We have a few customers in Europe and, of course, in Israel. We have customers in various industrial sectors. So, for example, pharmaceuticals, energy companies, water utilities, automotive, chemicals, food and beverages. It's a wide range of sectors, and I'll explain what we do to help them. In terms of investments, we have two angel investors. One of them is Shlomo Kramer, who was one of the original founders of Checkpoint Security. He then founded Imperva, invested in Palo Alto Networks. Now he runs Cato Networks. So he's not only an investor, invested both in the seed and A series, he's also on our board. In our A series joined us the former General David Petraeus, who was the head of the CIA. Very known persona. He personally invested in Indegy, so he's now part of KKR Investments. So they usually invest in later rounds. He personally joined our seed round. Three other VCs that are invested are Vertex. They led our A series. They are a global VC. The Israeli branch was the lead on this investment. Magma is an Israeli VC, and Aspect Ventures are a Silicon Valley-based VC. In terms of locations, we have our headquarters office in New York, and our R&D lab is based in Israel. I'm based in Israel. The founders of the company are Barak Perlman, Mili Gendelsman, and Ido Travitsky. The three of them met when they participated in the Talpiot program of the IDF. To those who are not familiar with this, it's a top elite academic program where they handpick about 40 participants every year, only 30 of them graduate. They go through rigorous academic and military training. They each have received their bachelor's degrees in mathematics, physics, and computer science before they joined the Army, and then they joined the Army in leadership roles. Barak was part of the famous 8200 unit and led significant defense projects there. Mile was mainly involved in research, also leading some significant research projects. And Ido, who is our VP R&D, is he dealt a lot with infrastructure and leading development projects. So the three of them came to the company with hands-on experience, not just with management and leading projects, but they also experienced during their service, they dealt with industrial control systems. And so when they left the IDF, they decided they wanted to address the gaps that they recognized during that service. Myself, I'm here as well, part of the management team. I joined about a year and a half ago. My background is more cyber-oriented. Before I joined Indegy, I was with Tristeer, which was acquired by IBM. Before that, I was with Imperva from the early days, and as you know, Imperva IPO'd. And before that, I was with another startup that was acquired by Symantec. So that's my background. So why industrial control systems? Industrial control systems, and I'm wondering if I see the panel, and I'm wondering if you're seeing it as well. It's okay here.
No, we see only your presentation.
Okay, fantastic, because it's blocking half my screen. Okay, that's better.
Just click the arrow. Just click the orange arrow on your right top.
Yeah, that's better. Thank you. Okay, so industrial control systems, ICS. These are the infrastructures that run all the industrial sectors. So whether we're talking about water, power and energy, oil and gas, manufacturing, transportation, even building management systems. Those are systems that you would find both in data centers and in large conference buildings or hotels. These are systems that include industrial controllers or automation controllers that make sure that the process is automated, continuous, and safe. So there's a central control center where you run SCADA applications, and HMI stands for Human Machine Interface. And from that control center, the operator will control the entire operation, whether it's a manufacturing operation or a process like oil and gas extraction or power and energy, etc. This infrastructure is quite sensitive, and let me say a few words about that. So what you see here is called the Purdue model. It's a simplification of the different networks that you would find in an industrial organization. By the way, I say industrial, I include critical infrastructure, of course, in the discussion. It's the same infrastructure supports electricity, water, everything you would consider as critical infrastructure. So what you see here in this environment is on the top we have the internet, right? That's the external world. And we have the corporate network, which most of us are familiar with, IT networks. We have the workstation servers, business applications. This is where we process all the data, the finances, marketing, etc. Then we have usually a SCADA DMZ, which separates the IT, the corporate network, from the industrial network. And then we have the operational network. The operational network typically, and it's, this is a simplification and it can vary from organization to organization, but typically we're talking about 3 layers. Layer 0 is the heavy industrial assets, turbines, pumps, generators, valves. Those belong to the layer 0. Then we have the controllers, PLCs, RTUs, DCS. These are the units that transfer the instructions to the pumps and generators, to the heavy equipment, telling them how to operate. Now, these PLCs and RTUs are not just proxies. They don't just deliver the instructions from the HMI stations and the engineering stations. They actually include logic. They are basically computers. They are computers, only they're not Windows-based or Linux-based. They are proprietary systems designed by vendors like Schneider Electric, Siemens, Rockwell, Allen Bradley, or GE. There are various manufacturers, but they are computers, and their logic is designed to make sure that the operation is safe, reliable, and continuous. Those are the 3 important things in an industrial environment: safety, reliability, and continuity. Unfortunately, these networks, because they were designed decades ago, and a lot of these technologies were designed to last for decades, they were designed without any security controls. So unlike IT environments where we have everything from authentication and authorization solutions, network monitoring, we have antiviruses, we have IDS, IPS, firewalls, and a whole gamut of solutions. Inside the operational network itself, we don't have these controls. For example, a lot of these controllers, these computers that control the process and are responsible for its stability, safety, reliability, continuity, they don't have even basic security controls like authentication. That means that you don't need a username and password to connect to some of these devices. In others, you use default passwords to connect to them. There's no encryption on these networks. So that means that anyone who has access to these networks can change whatever they want. And not only you can't restrict them from changing or making those changes, you can't even track them because there are no event logs, there are no alerts, there's no information about the activities that take place here. And of course, you can imagine that if I hook into a controller that is responsible for my water supply or for an oil and gas pipeline, I can cause significant damage. Okay? So this is really what Indigi comes to address. We are here to prevent operational disruptions, whether they're caused by cyber threats, malicious insiders, and human error. I'll explain these 3 in the next slide. But the way we address that is, first of all, by providing visibility and control in these industrial networks. So we fill the security gap by allowing you to see what's happening, who's operating, what are they changing in these networks. Regarding the threats that we see to industrial networks, we divide them into 3. The first and easiest to explain is, of course, cyber attacks. We are familiar with stories from Stuxnet, which is old, ancient, actually, to more recent examples like the hack into the New York Dam, the attack on the Ukraine, where they took the they blamed the Russians for taking the power grid down on Christmas Eve. And you can imagine during Christmas in the Ukraine, pretty cold and without power, that would be a problem. And there are many examples. So cyber attacks on industrial grids, industrial infrastructure are happening. Now, not only are they happening as an organization with an industrial control system, you should be worried even if you don't think that you'll be necessarily a target. So obviously, critical infrastructure would be a target of such an attack. But let's say you are a manufacturer and you think that your production lines are less significant and not likely to be targeted. There's still a high chance that you will suffer from collateral damage. That means that once a threat is in the wild, and it targets the same technologies that all these industrial platforms use, you might as well suffer from the same damages. And a good example is actually Stuxnet, and the only reason I use it is because it's a very known example. So Stuxnet was very targeted, and so the only facility that actually suffered any damage was the Iranian facility that was the target of the attack. But the same virus was found on Chevron's network. Now, they didn't suffer from any damages because it was a responsible, well-designed virus. You can talk about that. But what if a threat doesn't target the environment in which it needs to operate like Stuxnet did? But what if it targets any environment, reaches your network, and takes it down? So cyber attacks are a big threat. This is something that is well recognized in the industry. We don't hear anyone saying that they're not concerned about that. Malicious insiders, disgruntled employees, as well as any compromised devices that are already in the network are definitely threats. And we hear about incidents all the time. The reason we need to be aware of those threats is because it's not enough to just prevent threats from coming from the outside in. You need to also consider threats within your network. But probably the biggest threat among these three is human error. Human error happens all the time, nonstop. There are errors from working on the wrong asset or uploading the wrong program to a device and taking down the line. And these are, often they're unintentional, but it takes a lot of time to detect exactly what happened and respond to it. So these are probably the biggest fears of our customers. They all recognize a cyber threat. They all recognize malicious insider, but it's easier for them to talk about human error and the cost of human error to their operations. Human error can result in operational disruptions that are, it can take down a production line and cause financial damage, but it can also cause a wide range of physical damages, like cause an explosion in a pipeline, or cause spillage of hazardous materials, or take down the electrical network. Okay, and these things do happen on a regular basis. So when we talk to customers, the questions that they have a hard time answering is, when you have an operational incident, how quickly can you find out? Okay, it usually takes them anything between a few hours to a week to find out that there is a problem. And then when they discover that there is a problem, how quickly can they pinpoint the source of the incident? What caused it? Was it human error? Was it malicious attack? What changed? Did they change a certain device? What exactly did they change on that device? Was it a configuration change, a logic change, etc.? And then when they understand what happened, how quickly can they recover? Do they have the resources they need? And one of the biggest problems in these industries today is the fact that there's a shortage of professional resources. There are not enough engineers entering these fields. The older engineers are leaving, and so there's a shortage of trained people. How much damage will be inflicted during that time, and can you prevent it from happening again? Now, something I forgot to mention, and let me go back to this slide. I mentioned that these networks were separated in the past. There was a DMZ. One of the things that the main theme of today's webinar is advanced advanced manufacturing, advanced industry. One of the trends that we see today, and the previous presenters talked about, was IIoT, connected industry. With the introduction of connected industry, what we see is we see new devices that are now connected either to the corporate IT or to cloud solutions. And the reason for the development and deployment of such devices is, like the former presenters explained, is to improve operations, improve productivity, to do predictive analysis, all kinds of things that improve manufacturing. But the problem is that once you expose these networks externally, you also expose them to threats. And that today, the security concerns are the biggest inhibitor for deploying such solutions, because everyone realizes that once you connect these networks outside, and these networks don't have any built-in security controls, they don't have any security controls whatsoever to prevent compromise, you're in trouble. Okay? And these are the threats, these are the questions. So Indigy's solution is a software solution that is delivered as a turnkey appliance. We don't have any agents, it's easy to deploy. What it does is it plugs into the network in a central location, and it tracks all changes and all activities in the network. We actually do a few different things. The first thing we do is we discover all the assets, and this is pretty amazing. In these environments, we don't have asset management processes, nothing automated. If we do see organizations where they have some kind of asset management process or routine, it's usually a manual process where you have a human being walking around the floor with a spreadsheet and filling it manually. And of course, that's error prone, it's inaccurate, and by the time you finish filling it out, you need to update it because things change. One of the interesting stories that we have is we have a customer where it's actually a pharmaceutical customer where an integrator came in to work on a certain device, and they gave him the asset spreadsheet to identify the asset they need to work on. What they didn't realize is that a new DHCP server was deployed and it changed the IP addresses. DHCP server deployed the IP addresses. Anyway, he ended up connecting to the wrong PLC, changing it. It took them a day to realize that the right PLC was not updated. But when they contacted the integrator of course said, of course I updated it. Now they had to shut down the line, figure out which PLC was changed. And that's not easy because you don't have historical information. So how do you identify the one that was changed? It took them another day to do that. Meanwhile, they had to shut down all the assembly lines. Then they called back the integrator to fix it, to try to return the original PLC to the original state and do the work on the right PLC. So a lot of damage due to human error. So the first thing we do is discover what you have on the network. Then we monitor all the activities, both data plane and control plane activities. This would make more sense to an engineer on the network. And then there's an extensive API that allows us to share the information outside of our solution. One of the unique things about our solution is the value we bring. We bring value both on the cybersecurity side and on the operational side. So handing people the ability to manage their assets with an accurate asset inventory, manage configurations and change management. And on the cybersecurity side, of course, provide real-time alerts, do a risk assessment, and support forensics. I think we don't have enough time to do the case study, so I'll just stop here and I'll ask if there are any questions.
Dana, I'm afraid we don't have time for questions, but if someone has questions, then I'll send it to you and you'll reply and we'll send it back to all of the participants. Okay?
Fantastic.
Okay, so I would like to thank you, Dana, and the other presenters, Dr. Gili Fortuna and Noam from LightUp, and all the participants in the US, Latin America, and Israel. And special thanks to Zohar Amiud from GetWebinar for enabling us to conduct this webinar. So thank you, Zohar. And as I said before, we invite you to create engagement with companies and integrators who are looking for advanced solutions for the manufacturing process. So please feel free to send us, and we'll be happy to help and send you feedback. So thank you all. Until next time, goodbye.